Welcome back to the Automation Podcast. My name is Shawn Tierney from Insights in Automation, and this week on the show I meet up with Barry Turner of Redline, and we talk about 62443 Zone and Conduits and how you can easily implement them with Redline's Compact Intelligent Firewall, the RA10C. Barry, thank you for coming on the Automation Podcast. I'm excited to go through your presentation today, but before we get into that, could you introduce yourself to our audience?
Hey, Shawn, glad to be here. So thanks for this. My name is Barry Turner, and I am currently the Technical Business Development Manager here at Redline Controls. I've been with Redline for about 13 years in a couple different roles, always a technical role. Before coming to Redline, I was actually a network administrator for about 15 years. So I've been working in the IT field for about 15 years, half my career, and then the other half really supporting technically the application engineers for control systems.
Well, and I appreciate that because we could use your expertise. I know we had last year, it was a year ago, a year and a half ago, we had ISA on the talk 62443, but it was very, very high level. So I know you have more practical experience, especially with the products you manage over there at Redline. So without further ado, let me turn it back to you.
Okay, sure. So I just want to briefly give your audience a kind of an overview of some security models that they may be interested in implementing in their own control system to increase the security posture of their application. So the ISA IEC-62443 is a cybersecurity standard that's been around for a while. And really what that is a combination of a lot of things that we've learned from the IT side for the past few decades applied to a control system application or environment. And so, and the interesting thing is it's not just applied at the beginning, it's applied across the entire life cycle of your application. And within that standard, there are a lot of different security models and security practices that our customers can use or utilize to, like I said, increase that security posture to make their network and their application more secure and create some security measures that will help them be protected. So with that, let me kind of dig into, I've got a couple of slides here that I'll speak to. So if you're not able to see them, you can just listen. But I want to tell a story of a customer that I met a few years ago that had a problem that he came to Redline with. And that was that he had recently allowed a third-party contractor to come into his network and do some work that was required. And the controls engineer came in, the contractor, came in, did the work for them. But the problem was the laptop that this third-party contractor had was compromised. And so it had been compromised, and the site had not had full patch management implemented throughout their organization, so they had a lot of HMIs that were Windows-based. And so this Windows-based laptop that was plugged into the network, this OT network, was able to infect all of the other HMIs in the plant floor that were also Windows-based that were not patched. And so the customer said, hey, we just let a guy come in to do some work to, hopefully improve our uptime. And then we went backwards because we had a lot of downtime because we had to go around and resolve the issue. And then we had to patch all of our HMIs or Windows-based HMIs. And so it became a big issue for him. And so he's looking for a way to mitigate this from happening in the future. And so we start having a conversation around this cybersecurity standard here, 62443. And I mentioned, there are things that you can do like defense in depth. And so, and he's like, well, so what is defense in depth? And so we kind of briefly talked about that. Defense in depth just means that we are applying multiple layers of security measures to protect our assets from an attack vector. And so we're taking a look at and we're doing an assessment of all of our devices on the plant floor or within our application to understand what their security level is. And then we're kind of making sure that we add layers of protection so that we're not relying on just one thing to protect our network, but instead multiple things. And so the types of things that I would be referring to would be like physical security. Other things might be policies and procedures that are not in place today that would help protect that. And then zone and conduits. And so zone and conduits is really the topic that I want to talk today because it's very interesting, and it's typically pretty difficult to implement, to be honest with you. But Redline makes some products that make it a lot easier to implement that. So I just want to make sure your audience was aware that there is an easier approach here to implement this very helpful security model.
I want to just jump in here, and it's not just an integrator coming in with a PC that could be a problem. It could be your phone. You could connect to a Wi-Fi at a restaurant or at a coffee shop, and if your phone is hacked, if your phone is compromised, then that could be the vector that they get into your plant. And think about this. Even the charging stations at the airport have been known to be compromised and hacked. And so who doesn't bring their phone with them everywhere, right?
That's right. That's right. Yeah.
So, I mean, for the audience who are listening, if you have to go to upper management about this kind of stuff, it can even be your cell phone or tablet that could be the culprit. And unless you do like what some secured, very highly secured government mills do and not allow any electronics in, I mean, that is not the case today. Almost everybody allows you to bring at least your phone in. So, and of course, if you have people working for you, they got to bring their computers in. So let me turn it back to you, Barry.
That's a great example, and that happens a lot within an organization where somebody brings a third-party device with a phone, tablet, or whatever, and because it didn't go through the normal procedures to make sure that it is secure, opens you up. And then when you don't have these layers of defense, then you're kind of wide open. And so in this customer situation where he allowed this third-party contractor to come in and plug into just a gray sport that was there at the line one, that laptop was able to access every other industrial device on the plant floor, find all of his Windows-based HMIs, and then target them and infect them, and all without the third-party contractor knowing that this happened. And so they only knew it happened when the production line stopped. And so, like I said, a better approach here is to add those layers of protection that will keep, a would-be hacker or even something, in this case, wasn't a hacker, it was just an accident, from causing downtime on the plant floor. And so we talked with the customer about, the cybersecurity standard. We talked about defense in depth, and we talked a little bit about zone and conduits and how that would help him. So he wants to know more about zone and conduits. And so we start digging into what that really means. And so zone and conduits is really segmentation. So we're taking one large flat network and we're creating zones out of that network, which are smaller portions of the network. And so today that's done, right? So today it's done, but it's on a large scale. So if you look at the IT/OT side of the equation, you have one zone that's on the IT side, and you have a router that separates the IT from the OT. So there is a zone for the IT side, and then you typically have a zone for the OT side. The problem is that for a large number of our customers and a large number of industrial applications, that OT side is one large flat network. And like I said before, when you have one large flat network, everything else can see everything else on the network. And so you want to really segment that and isolate parts of the network so that data doesn't flow freely unless you actually want it to. So that is what the customer's problem was initially, was that when the contractor plugged his laptop in, it could see everything on the network. A better approach would be to create zones so that you can isolate one line or one cell from another line or cell. And then also, it's important to know that these zones that you're creating should be similar devices for the process control. So they should all be things that need real-time communication or need to be communicating very quickly, and they should all have the same security level. And so you're going to do a security assessment before you start something like this. So a security assessment is going to determine what security level is required for all of the different devices that you want to secure, and they should all be within, or all the devices within one zone should be of the same security level. And so that creates these boundaries that you can create around your application or portions of your application that were protected. So you can imagine if a controls engineer were to plug his laptop into line 2, for example, and then it was infected like before, instead of infecting the entire plant, he only infects those devices that are in that zone instead of the larger application. So that's a huge protection there. And so the next part that we need when we're talking about zone and conduits is the conduit itself. And so what function does the conduit serve? The conduit really controls the traffic going in and out of a zone. And so we definitely know that we need communication to go from line 1 all up the way up to the SCADA package, or maybe even line 2 may need to communicate, maybe that we have a peer communication between 2 PLCs or something like that. We do want them to communicate, but we want to have something in the middle there, that conduit that's going to control the traffic and allow just the traffic we want to allow. And we want some type of monitoring. So we want to be able to kind of monitor and log the traffic, or sorry, log the activity that's going across that conduit, so we can ensure that the activity that's happening is exactly what we expect. Now, typically, this type of method, so this type of model, security model, is done with implementing VLANs, and you would use something like a firewall and a router to get in and out of those zones. And so, in my conversation with this customer, he was really excited up until we got to the part we're about to talk to right now. And so he really liked the concept of the segmentation within his plant floor. He liked the ability to control traffic in and out, but the requirements to do so on a today's OT network, it's a task. It's a really big task. And so when we're talking about creating new VLANs, when we're talking about creating new networks on the plant floor, that means we need to change the IP address, the subnet mask, and the default gateway for every device on that network to allow it to communicate across that new conduit and over to the new zone, or to the zone that it needs to communicate with. And so that is a task that many controls engineers don't really want to take on, because one of the most important things to all controls engineers, and rightfully so, is uptime. And so you want that application to run, and you really don't want it to go down. So we don't want to stop making products. But now, if we make significant changes to the network, the potential for downtime increases a lot. A mistake in typing subnet mask, for example, or default gateway could really jeopardize the uptime that we need for our application. So this is the part where he was like, let's pause just a little bit. You're telling me that I need to make a change to all of my controls devices. So this application's been running smoothly for the past 5 years that's been running. Now you want me to make a change to it. And now that introduces a lot of risk for him. So he's like, I really want to increase my security posture, but that risk is a lot. And so that, puts them in a tight spot. They definitely want to do it, but then you have to figure out, the risk reward. And so the reward here is that increased security posture. But really where the win comes in is when you can use a product that makes it possible to do this without making those changes, without having to make major changes to the industrial network itself. In terms of IP addresses and mask and gateways, you don't really have to make a change, but instead just plug a device in the middle and then use a graphical interface so that you can configure who should talk to who, and then and walk away. And so that's really the solution that I want to talk about today, is Redline's RA10C Compact Industrial Firewall. It does that. And so it is a firewall. It also has a router mode. But if you use that product in bridge mode, you don't have to change the IP address of any of your devices on your network. All you have to do is put it in line. So put it in line with the from one zone to another zone, and it's going to control the traffic going from zone 1 to zone 2, and it will give you that monitoring ability, and then allow you to, like I said, control which devices are able to communicate across that boundary. And so that is a big win for the customer when he can implement this, when he can increase his security posture, when he can really protect himself and implement these security measures like this without jeopardizing the uptime that is so precious to them.
Yeah, for the audio audience, this product, if you haven't seen it on our show before, it looks like your standard 4-port switch, but the ports are on the wide side, not on the end. So that's it's a very unique looking product.
Yeah, it's a very low profile product, so it's not gonna take up a ton of space, in the panel itself. And it is just exactly what you said. It's 4 ports. 3 of those ports are what we would consider the LAN side, and then the other one would be what we consider the WAN side. And really all you're talking about doing here is plugging the WAN into one zone, and then one port of the LAN into the other zone. And then you configure it using that graphical interface, which is what I'm showing here. There's a graphical interface available to our customers with the MBNet Fix software, which is free download off our website. This software is great in that it gives you a graphical representation of the communication that's trying to happen across that conduit. And so you didn't have to go in and collect the IP addresses of all of your devices that are trying to communicate. You just plug this device in place. It's going to intelligently identify them and list them in a format like what you see here. And then all you have to do is press the check mark if you want to allow that communication, or the no if you don't want to allow that communication. And what's happening in the background for you is there are rules, the firewall rules that are being put in place that will allow or disallow the traffic in the way that you want to. And so you're able to set this up without being, well, a network engineer. You're able to set this up with, almost no downtime, because it's so quick and easy to set up.
So here I could say, let's say I had a PLC that had to talk to another PLC and a SCADA system who had to talk to that PLC. I could just allow those two nodes and say, everybody else, you shouldn't be talking through this.
That's right. And that really is how the network should be set up. Traditionally, the OT networks, we leave it wide open, and we want it to communicate because we need it up and running. But really what we should be doing is kind of isolating this traffic and only allowing things that to communicate with things that it is necessary to communicate with. So someone in the front office should not be able to access the IO or the VFD in any way. And so implementing something like this zone and conduits security model will prohibit that kind of conversation, because you can use a firewall at each one of those zone boundaries to prohibit that type of connection. So a little bit more information about the software itself, Shawn, is that this software is designed for controls engineers. So instead of understanding exactly how firewalls work and understanding, layer 2, layer 3, layer 4, you don't have to know any of that. You don't really have to understand much except for walk through the wizard, the setup wizard that the software has. And there's security built right into the device. And so there's secure boot, for example, that's built into the device. And then when you set it up, you're going to create an RSA key, so you can actually lock down your project configuration. So, it could be on your laptop, but, if your laptop were to be hacked, an individual who had, gotten access to your laptop couldn't just open up this configuration and do anything with it, because it would be protected. And so it's a very, high secure device that's very easy to use. And so that's a balance at Redline that we really strive to get, and we normally do.
Can I ask you a question? So this setup looks super easy and very very easy to understand and set up and deploy. And I was reading recently one of your case studies where you use this to block traffic from going to radios. Are you familiar with that case study?
I mean, we've run into that quite a bit. And so if you are referring to radios, so a couple things about radio technology. It's not full duplex communication, so it's a half duplex connection or communication. And so you really don't want to send a whole lot of information across that expecting real-time response. And then sometimes, depending on what type of radio you're using, but if you're using a 900 megahertz radio, for example, that's a very low bandwidth. And so when we're talking about using a radio like that, and then we're combining traffic that is generated on the OT or maybe even the IT side, that traffic, and some of it is broadcast, and some of that broadcast traffic can be quite chatty. And so if we have chatty broadcast traffic that's trying to go across this radio link, then we need to lock that down and prohibit that from going out the radio link, because it's just going to block up the low bandwidth link that we have that's not full duplex. And so what that means is that you can use a product just like this to allow or disallow, using that graphical interface and say, hey, I do not want to allow this traffic from this host to go across this link, and then that will solve that problem completely.
Yeah, and that's exactly what you guys said in your case study, and I can see it now visually that you basically disallowed all traffic to the radios except for the one PLC that was supposed to be polling those remote stations, and boom, no more problems. That's very interesting. Now, let me ask you another question. So what we're seeing here is the simplest, easiest to understand setup where allowing or denying by IP address. Is there any deeper levels to this?
There are. So the link right there that you see, filter mode and rules.
Okay.
So if
Yep.
you dig into rules, you have just your standard firewall rules. And so clicking on this interface here is actually going to create those rules in the back end for you. So once you click over after going through this page here,
Mhm.
you'll see a number of rules that are listed out there. And then from there, you can really fine tune it how you want to. So if you wanted to allow host A to talk to host B, but only use an Ethernet IP and nothing else, you could certainly do that.
Okay, great. And I could like enable or disable like port 8080
Hmm.
or port 21 if I had an FTP server. So I can go
Exactly.
through there to that granularity and turn things on and off.
That's right. And another feature that's built into this piece of hardware that I think is really unique is that you can have firewall rules that you can engage and disengage based on IO. And so what that means is that maybe there's a situation where I want to be able to program this PLC, use my RS-Link software, but I don't really want it open all the time because I'm only going
Oh.
to do this maybe a couple of times a year or maybe
Mhm.
less. But I don't want to have to go all the way out there to enable that. You can actually enable that, tie that in with maybe something on the HMI or something in the control system that somebody presses a button, and now this firewall rule is enabled, and now you get to have the conversation that you're looking for, or the connection you're trying to get, and then once you're done, you shut that off, and now you can't communicate with it anymore.
So this device has an input that can say
Hmm.
that can be a permissive that says if this input comes on, we will allow this to happen. If that
That's
input
right.
goes off, we block. Oh, that's awesome.
Yep.
Yeah, that's definitely something like you put on the HMI or you put a key switch on the front of the
Hmm.
panel and you only allow remote access when somebody on the plant floor says you get that access. And that
That's
may
right.
not just be for VPN, that might be for the guy up in the engineering office because you know what? I don't know how many times has somebody done something in the engineering office and the guys on the plant floor were steaming mad, right? So
That's
I
right.
love that. That's great.
Yeah, it saves them from having to make a trip all the way out there
Hmm.
to try to make a change. They can do it right from their office many times. And then again, it puts control at the end there. So whoever the operator is that needs the controls engineer to connect in, he presses the button, turns the key, or whatever he needs to do to allow that conversation to happen. And then once he's done, he shuts it off.
Yeah, and if you have a bit in the PLC that tells you whether you're in production or not, you can use
Hmm.
that. So hey, if
There
the
you go.
when the operator takes the machine out of production, it opens it up for the engineering guy in the office to come in and take a look and see what's going on.
Exactly. So a little bit more about the RA10C firewall itself in terms of the specification. So this is an intelligent firewall. It is a low profile device. So like I said, it doesn't take up a whole lot of space in your panel. It learns on its own, so it's able to detect the communication that's trying to traverse the router or firewall itself, and then allow or disallow based on what you put in there. But it also has that secure boot that we talked about, and you can filter on IP address, so we can block it based on, hey, this source and this destination IP address. We can block it also on the protocol that we're trying to use. So, like I mentioned earlier, we can say, hey, just Ethernet IP, but nothing else across this conduit. And then if you're using this device in router mode, now if you're using router mode, it's just like a traditional router, which would require you to make a change to the industrial devices. But this device does support bridge mode, which is what I spoke about at the very beginning, but it also supports router mode. In router mode, you can use NAT and simple NAT and port forwarding to get access in and out of a particular zone. Um, it's also, it's an industrial device, so we're talking 10 to 30, volts. And then it also, it's a DIN rail mounted, and it's a very small device. And when I say small, I'm talking about, 69 millimeters to 38 millimeters by 92 millimeters, something like that. So it's a very small device, mounts right on the DIN rail, very compact and very easy to use.
So if I'm an OEM though, I can use this as a one-to-one NAT device if I don't need
That's
it to use it as a firewall.
correct. Yeah, and we do sell it that way a good bit. So any controls engineer or OEM, like you said, that has a building some machine and is many times it's cookie cutter. So the PLC and the IO are the same exact IP address in every one of the machines that they build.
Hmm. Hmm.
But maybe this, one customer buys multiple machines, and so, but we want to pull data out of that. So when you have the same IP address or IP address duplication within your network, it's going to cause problems. Putting a device like this and using the NAT technology is going to allow you to separate those, and so that you don't have the duplicated IP address, allow them to communicate out and allow you to communicate back in. And again, with the RA10C, you get that graphical interface to configure all that.
Now I noticed that there's a USB port on the front of it. Do I have to program via USB or can I program via Ethernet?
You do have to program it via USB. So today, when you pull up when you open up for the MBNet fixed software, you're going to connect USB in from your laptop to the device, and you're going to create a project. And your project is just really the configuration. You can do that configuration offline, or you can do it online. If you do it online, you're connected over the USB, but it's really doing a USB over IP to communicate with it. And then it is at that point a very secure device and has fewer attack surfaces. So there is no web server built into this. So you're not going to be able to. So someone's not going to hack port 80 or 443. It is a security centric device that has less attack surfaces than many of the devices out there.
Yeah, that's I can see the positive of that is that, hey, you have to physically plug into it to connect to it. You cannot hack it through the network ports. Very interesting.
That's right. And once, usually once these things are set up, it's set it and forget it. It's out there and it's done. And then if you do need to make, if there are dynamic changes that need to be made to the firewall rules, again, you could use that IAO to enable and disable rules.
Yeah, and like once you set this up, it's very rare that you would add a new SCADA system or a new PLC that has to talk to the existing PLC. But if you did, you're already doing some physical wiring down there on the plant floor anyways, or doing some major setup. So just walking down there and plugging in shouldn't be a big deal.
Right.
To get that done. So, all right, great. Wow, what a very interesting product, and I really appreciate. Was there anything else we wanted to cover before we close out the show?
I think that's really about it. Like I said, I just really wanted to impress upon your audience the importance of using some of these security models that are in 62443. Encourage them to, seek out more resources to learn how to increase their security posture, and use products like the RA10C to make that implementation as easy as possible.
Yeah, I can definitely see, like I've seen some of the setup for some of these high-end firewalls, and it makes your eyes water. If you're not like, I don't have your background, I have a PLC background, so it's like something like this where the software is intuitive, easy to install, easy to set up, and it doubles as a NAT device too, which is great. So it can kind of play two different roles. Is really good, and it's not. We say it's for security, but it can also be for, like we gave in that example with the radios, to kind of keep the traffic off the radios as well. So a great little device. And Barry, I really want to thank you for taking time out of your busy schedule to come on and tell us all about the Redline RA10C.
Well, thanks for having me. I really appreciate it.
Well, I hope you enjoyed that episode, and I want to thank Barry for taking time out of his busy schedule to come on the show and bring us up to speed on zone and conduits and tell us about the RA10C Compact Intelligent Firewall. Now, if you did enjoy this episode, please give us a like, a sub, and a share, because that is the fuel that keeps us on the air. Also, if you want to join our community or just follow me, you can do so over at automation.locals.com. And of course, you'll find all my training courses over at theautomationschool.com. With that, I want to wish you an awesome week, and I want to encourage you to stay courageous and stay fearless. And until next time, my friends, peace.